Hello statistics students, Mr. Guzzato here. Today I want to go over independence. So if you read the top of the page, two events are independent if knowing whether or not one event has occurred does not change the probability of another event happening. The mathematical definition is the probability of A given B is equal to the probability of A. In other words, knowing that B has occurred does not influence the outcome of A. So let's take a look at an example. So for part A of the problem, we want to calculate the probability of A given B. And we know from our definition of conditional probability, that's probability of A and B over probability of B. Then using the paragraph, we can see that the probability of A and B is 0.1742. So this is equal to 0.1742 divided by the probability of B. And using the paragraph, we can see that the probability of B is 0.26. So when I divide those two numbers on my calculator, I get 0.67. Now if you notice that this 0.67 is the same as, and I'm going to circle it in red, the probability of A. So since the probability of A given B is equal to the probability of A, these events are independent. If you do not get 0.67, which is equal to the probability of A, they would not be independent. Let's take a look at a second way of justifying if two events are independent. A second way to check if two events are independent is to use what we call the multiplication rule, which I'm going to highlight in green. So if the probability of A and B is equal to the probability of A times the probability of B, the events are also independent. So for this particular problem, for part A, I want to calculate the probability of A times the probability of B. Using the paragraph, I see 0.77 and 0.28. So I'm going to write that down. 0.77 times 0.28. And multiplying those on my calculator, I get 0.2156. And if you notice here, this probability of A times probability of B is equal to the probability of A times B. So since the probability of A and B, I just circled this in red, is equal to the probability of A times the probability of B, the events are independent. Let's take a look at an example that has some context in it. Let's take a look at this application. You've recently applied to NIU and ISU and believe the probability you'll be accepted to NIU is 0.62, and that's where I graduated college and have my master's degree. The probability that you are accepted to Illinois State is 0.33, that's where my daughter and son go to college. And the probability that you're accepted to NIU and ISU is 0.2046. So your goal is to figure out if these are independent or not. So part A is asking us to use the multiplication rule. So the probability of NIU times the probability of ISU is equal to 0.62, the yellow number, times 0.33, the blue probability. And when I multiply those two together, I get 0.2046. Now, since this probability is equal to the probability of NIU and ISU, so you notice that this number is the same as the pink number, they are independent. The second way we talked about justifying independence is to use conditional probability. So if I were to check probability of NIU given Illinois State, that's the probability of NIU and Illinois State over the probability of Illinois State, which is equal to 0.2046 divided by Illinois State 0.33. And dividing those two numbers, I get 0.62. So if you look at Part B, you can see that the probability of NIU given Illinois State is 0.62. And that is the same as the probability of being accepted to NIU. So since the probability of NIU given Illinois State is equal to the probability of NIU, this also justifies that the two events are independent. Now you only need to do Part A or B to figure out if they are independent. You don't have to do both, but I wanted to show you both examples. Let's take a look at one more example. Right. So this is the same context. Probability you're accepted into Northern is 0.7, ISU 0.35, and both 0.2007. So let's just go through the calculations here. For Part A, the probability of NIU times probability of Illinois State is equal to 0.7 times 0.35. Multiplying those on my calculator, I get 0.245. If you notice here, probability of NIU times the probability of ISU does not equal the probability of NIU and ISU. So this number, I'm going to circle it, actually I highlight it in orange. This number is not equal to 0.2007. So at this point you know that they are not independent. However, there is a second way you could do this problem. If you were to calculate Part B, the probability of NIU given Illinois State, that's equal to the probability of NIU and ISU over the probability of ISU, which is equal to 0.2007 over 0.35. Dividing those two numbers, you get 0.5734. And this number here is not the same as the probability of NIU. So since the probability of NIU given Illinois State is not equal to the probability of NIU, that confirms that they are not independent. And as I said previously, you only need to do one or the other to justify independence.